Greetings everyone, and welcome to this Urjanet webinar. I'd like to thank everyone for taking the time to join us today and hope you find this a valuable use of your time. My name is Tim Porter and I'm responsible for all of our OEM and channels relationships. And I'm joined today by DJ Amos, who is our Director of Product Management. He is responsible for the product and for all the feature sets that we deliver and getting feedback from our customers. So our goal today is to provide you with an introduction to our energy data service and to provide some specifics around how it works. I'm going to provide that overview and then hand it off to DJ to give more details on some specifics around the product. But let me begin by giving you a quick 10,000-foot view of what Urjanet offers. So in a nutshell, Urjanet is an energy data service. We focus on automating the collection and delivery of utility data. So our technology captures utility billing data, advanced metering data, and weather data, puts it in a standardized format, and delivers it through a cloud-based subscription model. And with thousands of different utility providers out there, our partners really understand how difficult of a problem this data collection issue can be. Industry analyst Urjanet recently stated that the volume, velocity, and variety of managing energy data really does overwhelm many companies. And so we solve that problem and the pain points around it, specifically around the capture and normalizing of the data, so that our partners can focus on the important stuff, the analytics that can be provided, and the services and energy strategies that can be put in place once you have insight from this data. So the more detailed the data, the more accurate the data, the more timely it's made available to you, the better the energy management solution or the better the energy service can be that you provide to your customers. So better data really does equal better solutions, and that's really what our goal is. Our goal is to enable energy management software and energy services companies by giving them a solution for collecting their customers' utility data that they need within their applications and for their service offerings. So this is really all we do. We're plumbing, I guess, is a good way to describe us, and all we do is provide the data that's really hard for our partners to get, and we don't do applications, we don't do energy services, we simply want to automate the collection and delivery of this data. This chart is from Urjanet, and it identifies 6 different areas of what they call big energy data software. And we're in the bottom right corner. You can see us in the data service providers section. And this really is what we do, and we do not get outside of this box. We know that capturing the data is, in fact, a very common problem and really a problem that's ripe for automation, because many of the leaders in the energy management software space have either already integrated or are in the process of integrating our data feed into their applications. And we really provide the data that's needed by all of the other 5 solution categories that is on this chart that Urjanet has identified. So we really are trying to be the plumbers that provide the data for all these other solutions that exist. So how does Urjanet work? What does our platform do? This diagram gives a good 10,000-foot view of what it is that we provide to our customers. But if we start by looking at the utility bill solution in the top left, in essence, we take tens of thousands of utility bills across the huge number of utility providers and turn that data, all of the data from those bills, into a single normalized data feed for our customers. So this data can be used for delivering both historical data from the bills in the past, as well as all the new bills in an ongoing fashion going forward. So this is really a very difficult problem to solve. It took us a while to get the platform in its current state. If you look at just how many providers there are in the U.S. just for electricity, the number is over 3,000. So that's just for electricity. And our intention is to be a many-to-one kind of solution that covers all of those utility providers and allows our partners to just rely on us as a single data feed that covers all of those sources. So DJ in a minute will give you a little bit more detail on how we've automated the collection of this data from such a disparate set of providers. But it's really important to note that it's all done through software. There's really no manual human data entry involved with our collection and delivery of this data. In fact, that's really one of the main reasons our partners use us. That's to eliminate the costly and the error-prone manual entry of this data, or to eliminate the need to build custom one-off integrations for each and every one of the utilities that their customers are getting data from. So that is the basis of our fundamental offering with the utility bill data delivery. We also do this data collection and delivery for interval data, for advanced metering data as well, in a product we'll be releasing here very shortly. And this has had tremendous interest in the energy services and the energy software space. Instead of collecting data from monthly bills, this solution actually collects time-based interval data that the utility providers make available for the customers who have smart meters. So this is really a big data solution with interval data readings typically happening every 30 minutes, every 15 minutes, maybe even every 5 minutes. We gather and store all this highly granular data and deliver it to our partners in the same way that we deliver their customers' monthly bill data. So there's tremendous interest in that product as well. The weather data solution provides hourly-based geocoded temperature data that is really beneficial when it's combined with the other consumption data that we provide to our customers. We have a unique way of collecting this data that makes it really accurate and tremendously more useful than typical weather feeds for customers who really want to see how weather is affecting their energy usage. And DJ will go into some more details about how it is that we uniquely provide that solution. So before I hand things off to DJ to provide some more detail on the specifics of the solution, let me summarize the key benefits that companies are seeing from our data service. First of all, the automated collection and delivery of this data really eliminates the need for manual data entry and all the costs and all the time delays and all the human effort that's associated with doing that. Secondly, this automation also eliminates a risk of manual data entry errors, so it really increases the accuracy that you'll see. There's bound to be errors when you have manual data entry happening across hundreds or thousands of energy bills every month. We also provide much more data than a lot of people are typically getting access to. So as an example, you wouldn't want to equate us to an EDI feed. We provide all that an EDI feed would provide, plus a huge amount of additional data. If you look at all the data that's on a bill, there is a tremendous number of data elements, and we collect every single last one of them from all the different providers that we support. So more data also means that in addition to getting this broader set of data, we can go backwards in history and have instant access, provide instant access to all the historical data as well for any of the energy accounts that you're worried about. Another key benefit is that the data we provide typically is going to get to you much, much faster because it is an electronic automated system. So as soon as a utility bill is provided, as soon as an interval data set is made available from the utility, we recognize that. We're always looking and polling for that data, and we deliver it as soon as you want us to get it to you. So generally, you will be able to bypass all of the slowdowns of mail delays and late fees that can involve if you are responsible for paying any bills, and we will get that data to you just about as quick as you could expect because it is an automated electronic solution. And lastly, we provide much faster access to new utilities. So if you have new customers that come on board that have new, smaller, maybe less used utility providers, it's very simple for us to expand our platform, and that's happening every week as we add new utilities to the platform. So now that we've covered a brief overview of the capabilities of the platform and some of the key benefits, DJ can provide a bunch more detail than I can on the specifics of our solution. So let me go ahead and hand things off to him and let him provide some further description on what it is that we do.
Sure. Thanks a lot, Tim. Good afternoon, everyone. I'd like to just go into a little bit more detail, maybe give a little color on the three core data sources that Tim covered. We'll start first with our primary data source. This is frequently the service that is primary for the customers that we generally see. This is sort of step one for most customers. They want to make sure that they first source an energy management program or a project to do better energy budgeting with, reliable, consistent invoicing, utility invoicing data history. So this is really for us sort of the central of the three data sources. And I'll just go into, again, some coverage of the challenges that this involves. Tim mentioned some of these. First and foremost, for anyone that wants to make sure they cover, the entire portfolio of their services, is just the number, the huge number of providers that are involved just in North America, the variety of electrical, natural gas, other service providers, and with that variety, they all have their own unique and different approaches to how they bill and how they source the information. There are going to be larger investor-owned utilities that have sort of moved into the data age and have several options of electronic data access. They're also on the other end of the spectrum going to be providers that still service by and large their customer base with traditional mail and paper services. When you take into account that there's, again, this huge number of providers, as Tim said, just focusing on electricity and natural gas in North America, we're probably looking at somewhere 4,000 or 5,000 different providers. And when you take that amount of parties and then also factor in the fact that they're allowed to bill in their own unique ways, there really are no set standards when you cross state lines or public utility commission region lines. There really are no rules that, all electric commodities need to be priced this way and all natural gas rate schedules and tariffs need to be priced this way. So the freedom to be somewhat creative in how they bill, the huge number of different providers just creates a big complexity there. How in the world can one customer effectively go in and map and store, make preparations and plans for that kind of variety? And those two issues obviously lend to the other challenges mentioned here. Data volume in and of itself. When you have this many providers, when they're allowed so much freedom in how they bill and measure the commodities for their customers, you've got to make sure that you've got the ability to store all that complexity, all those options, all those needs to pivot and rotate the data and store that. So data itself, the volume of that data becomes an issue. And whenever any of your options involve any manual processes, anything that's not as tightly controlled of a system, you're going to have consistency issues over time. How do you make sure that a successful deployment with one utility is going to be as successful when you do the second or the 100th or the 1,000th utility as well? So our solutions to these sort of challenges really revolve around the fact that we did design a storage architecture, an energy data model with electricity and natural gas and steam and sanitation and water and all the primary utility services in mind, and with a vision to impose standardizations and normalizations on all this variety. I mean, we refer to the model that our engineers employed as a federated data model. Essentially, we allow all the complexity, all the variety, what we call source fidelity, to be maintained, but then make sure that things get categorized and referenced and linked so that when we move the information downstream, customers can identify whether or not we believe a time of use charge or a time of use schedule behind San Diego Gas and Electric can or can't be compared to a time of use seasonal rate behind a certain tariff in Georgia Power in Atlanta, Georgia. So first of all, it's the model itself, the ability to impose those standardizations across all the different data sources we're going to see. The second big advantage of that same model is that because we're utilizing cloud resources, we're really able to solve the scalability problem that comes with the data volume and the challenges with consistency over time. We can fit any one customer or a customer's customers' needs to our cloud deployment. When we know we need to process a certain number of different providers, we can actually ask our resources to fit that problem. Technically speaking, we can process tens of thousands of invoice statements for a customer really in the same way that we would process one. If we know we need more resources, if we know we need to meet a certain timing deadline, we can always fit the cloud resources to that need. And then the final thing really here about our solution that the model grants us and the cloud deployment grants us is just the ability to manage what we call here anomalies. I mean, we're essentially doing sort of continuous commission on the data. I think Tim mentioned a little bit about how we poll our sources. By and large, with this data set, the utility billing data, most of this information refreshes on a monthly basis. I mean, this is sort of common sense to what you've seen. You're getting billed usually on monthly cycles, maybe quarterly, maybe a little less frequently, but that's the general rule. And so even though this data may only refresh once a month, we're going out and polling sources on our customers' behalf, usually every day, just to make sure there hasn't been a change, there hasn't been an update, there hasn't been some sort of rebill activity. And when we go out and touch those sources or poll those sources, we're also submitting them to a little gauntlet of data audits and data tests, and that's something that we just maintain indefinitely. Whenever new data comes in our system, whenever data is reconfirmed, it's submitted to those audits, and we can constantly make sure that we're receiving the meters we expect, the tariffs we expect, the charges we expect, et cetera, et cetera. Talk about the second of our primary data sources now, advanced metering data, referred to as AMI or AMR. I mean, again, Tim mentioned this, but these are your smart meter deployments. This is sort of digital meters that allow customers that are more focused on demand management to sort of move beyond the data that might be contained in the tariff or in the monthly billing invoice, but to be closer to real time and start making decisions in a more sort of detailed view. And the challenges here, primarily the biggest one for a lot of customers that want to incorporate advanced metering or digital metering data into their energy management program, is going to be a capital requirement. A beginning of many projects that get scoped to bring in more advanced metering information are going to require that you actually go out and deploy or purchase sub-metering equipment. Usually the hardware is also going to be paired with some sort of software investment as well. And so that's the first major challenge. If you want to make sure, if you want to guarantee that all your facilities are going to have coverage, frequently there's going to be a demand there to make some sort of investment in actual hardware. The second thing is for customers that are unable or unwilling to actually start an incorporation strategy that way with a hardware investment. There obviously are utilities out there, some of the larger investor-owned utilities and even some of the smaller ones that are starting to make the real-time data or the interval data available to their customers, depending on their tariff or the industry that they're in. But it's difficult still for customers to know exactly where that's available, whether there are any sort of applicability clauses, whether they qualify for that data, whether that data is a value add through that utility territory, or if there's some sort of enrollment in a program that might have some pricing barriers. And finally here, a challenge is, as opposed to the invoicing information, which is from a data point by data point comparison, maybe not as severe of a storage challenge. Here, the advanced metering data can really become an extremely voluminous data set. You can imagine a corporation or an enterprise that has hundreds of locations, maybe thousands of locations. Behind that, each location potentially having multiple meters reading at 30, 15, or 5-minute intervals. Those data sets grow to be very large very quickly. Our solutions here to these sorts of challenges are, first and foremost, none of our implementations are going to require sub-metering. I mean, we have the capability to communicate with customer devices. We can sort of serve as a value-added network in situations where that's applicable. But our standard solution is to go in and help measure a customer's utility footprint, determine based on that footprint which utilities are going to offer AMI data sources. We'll go in, confirm that map, and make that data available to the customer without new software, without licensing, without any hardware requirements. And in much the same way that a big strength of our model in referencing all the invoice data information is normalization of all the differences in tariffs and measurements, we do the same thing with the AMI sources. I mean, we're familiar with sort of the more common standards that are starting to emerge, the green button, which started in California, Energy Direct from the Southern Company, the WattSpot program behind ComEd, and frequently we just have a lot of providers that have built their own sort of proprietary approach to storage and delivery of AMI information. But again, we look at all those approaches and create a single format that allows us to store, impose our own structure, our own categorizations on all those sources, and then deliver them in a unified way to your customers. Also, obviously here, the fact that once again we're deployed in the cloud means that the storage requirements here will not be a barrier to us, and therefore not a barrier for your customers, for access and retrieval. The third of the core data sets that we wanted to talk about today is our weather data offering. And here again, the focus is really on customers with a focus on sort of demand management within the energy program. And primarily when a company or a program starts to integrate weather information, they begin by looking at sort of what they think the impact of heating loads or cooling loads will be on their facilities, their portfolio. And one of the most common tools available out there, especially as sort of a step one or a stage one, is to try and leverage historical degree day information, judge sensitivities of all your facilities envelopes, and make some assessments about what role temperature, humidity, and outside conditions have on your locations. So in general, the big challenges to this, again, differentiating a little bit from the AMI and the interval sources that we mentioned earlier, is for the most part, a lot of weather data, electronic weather data, has been available for some time. It's more readily available to most of your customers. They're going to be somewhat familiar with the larger players, AccuWeather, AccuData, NOAA, things like that. But we still see a significant amount of deficiency in some of those typical sources. By and large, the information is sourced first, frequently with heavily summarized information. One of the most common sort of shortcuts that occurs out there in these historical weather data databases is to take sort of daily highs, daily lows, maybe a relative humidity number, and sort of categorize weeks and days from only that summary information. In the same way, degree day information, by and large, is almost always going to follow the 65-degree set point standard, which is used in North America, and sort of the equivalent that's used in Europe. What we tried to do in the same way that we wanted to source our AMI data in order to give added value to people who are already receiving our invoice data streams is to just offer more granularity. That's sort of the same goal with our weather data product. We wanted to bypass just the heavily summarized weather information and go out and utilize weather stations, as many weather stations as we could. Right now our library is archiving somewhere a little north of 4,000 weather stations that are certified by the FAA or NOAA as stations that will always report hourly observations. Our goal is to go in and build a data set that's based on 24 certified, verified readings every day, so that we can actually track through the course of any day temperature swings and not be forced to rely on just heavily summarized numbers. In the same way, we did not want to be inflexible with the way our customers could utilize degree day impacts. So the second sort of solution in our weather data product that we offer that we think is unique is we give customers the ability with our implementation model to sort of personalize or tune the settings of how they want that hourly weather observation data to be used. Customers can set points other than 65. Obviously, customers are going to have knowledge about their own locations, whether or not they actually begin to cool a space when it crosses the 65-degree mark, whether or not they actually begin to try and heat a space when it moves below the 65-degree mark. So we'll give your customers the freedom to set different set points by location, to set operating hours as a factor to either ignore certain hours of the day or emphasize certain hours of the day, depending on what's changing in their schedules or in their strategies. And finally, we allow the ability to actually deploy these weather observations and these calculations at the meter level. You can have a very large facility in which the local engineer is positive there are going to be meters on site that are absolutely sort of invulnerable to outside conditions. There are going to be meters inside that building envelope that just will not respond based on the equipment that they support, and those can be excluded. You know, we can really focus on specific meters, specific accounts at locations, factor in the operating hours, factor in the customized set points, and then we believe deliver to your customers weather impact gauges, weather impact barometers based on what we call operational degree days that we think are much more actionable and much more valuable than sort of the standard information that's published by the AccuWeathers and the NOAAs with respect to just daily temperature averages and 65-degree set point degree day studies. So those, again, in closing, those are the three core data sources that we offer: our standard Urjanet Connect invoice data stream, the Urjanet Connect AMI stream, and then our weather data service.
Thanks, DJ. I appreciate you going into those details. This is a quote that you now see from Paul Beyer of Groom Energy, where he states that data acquisition can represent up to 50% of the overall project cost of a sustainability management solution and causes risk to the success of the project. And the important factor to notice about this being 50% of the overall potential cost, this is a cost that doesn't go away once you've got it implemented. So this is an ongoing cost, that the data is something that needs to continually be getting accessed and provided throughout the life of any kind of energy management system or solution within an enterprise. So it's very important that this is something that gets addressed with some automation and something that helps remove this risk from the success of the project and increase the likelihood of its success and hopefully lower the cost of its implementation. So again, thank you so much for attending. I think we've got a couple of questions. Maybe, Eric, have we had any questions come in on the webinar so far?
Yeah, we have. I see we've got a couple minutes left here, so let's get right to it. So first question is, what format is the data provided in?
Our standard format is delivered in XML, and we also have a standard CSV format that we're making available as well. But generally, we provide this in XML, and we can provide the schema for that for people to do their integration.
Okay. Next question, how do I get the data into my system?
Great question. We have the notion of what we call adapters. Adapters are what are written to take our data, consume it, and then apply it to whatever formats or APIs that you have into your system, into our partner systems. We can build those for people, or we, through the providing of our XML schema, can let people build it on their own. We've built many for our partners already, so we're very fast at building them. We can do them very cost effectively as well, but it's an adapter that gets built, and either we can build them or our partners can.
Okay, great. Next question, how frequently is the data delivered, and how is it delivered?
The frequency. So the frequency is something you can really set as our partner. It is monthly data if you're looking at utility bill information, but those get delivered on different days of the month. So you can either have us deliver that data to you on a monthly basis, or some customers want it more granularly and get it every week. Even in some instances, we deliver it every day to people. Certainly for the interval data, that is how we would expect to be delivering it, would be daily. But that's something that's completely in our partner's control. They just tell us how frequently they want it delivered. And the mechanism is generally secure FTP.
Okay. So how is the solution different than using EDI? And kind of a follow-up question to that, so are you similar to EDI in that the paper bill goes away with the Urjanet solution?
That's actually a question we get asked all the time. So we alluded a little bit to this earlier on. The EDI data set is just much more narrow than what it is that you'll get from us. It'll provide you everything you need to pay the bill, some of the financial pieces of the bill. But if you look at an energy bill, and this is different from provider to provider, there is a tremendous amount of detail that's provided regarding tariffs and meter numbers and everything that goes into your consumption for that period, and we capture every single element of that. So the biggest difference in summary is just we're providing way more data than a typical EDI feed would. One of those pieces of data is an actual image of the bill. so the bill doesn't go away. It actually stays in our cloud database, and so it's in essence we're a repository for the storage of those bill images in perpetuity as well.
Okay, next question is around interval data. So is the interval data real time, and what type of meters do you support for interval data?
The current interval data solution that we have, the AMI solution we have, is we classify as day-old data. So it's not real time. We call it kind of the next best thing to installing sub-meters that are going to wirelessly deliver to you in real time the actual meter readings. But day-old data, because we're getting it from the utilities, it depends on how quickly they make it available to us. But as soon as it has made available to us, we will consume it and we can deliver it. Since we're getting it from the utility, it really doesn't matter what type of meters it is that are being used to provide that data. So really whatever legacy devices, whatever vendors are being used for the smart metering is not an issue. Any way that the data is provided through the utility, we'll be able to consume it and deliver it to our customers in a normalized way.
Okay, last question. So is the solution available in international markets, specifically Canada, Mexico, or India?
Yes, it is, and we are following the path of most interest by our partners. So as new providers are being requested, we add them to the platform. Currently, we do support many providers here in the U.S. We've been asked to expand into Europe and into Mexico and South America, and I believe we've started our integration efforts in India. But again, the platform is intended to be expandable. So part of the value we offer is, as we said before, adding new utilities and adding new providers into our platform is not difficult. And as we go into the international market, we've already begun to tackle the problem of managing languages and that kind of thing that will show up on these international bills.
Okay, thanks, Tim.
So once again, thank you guys. I think we may be just a minute or two over. Appreciate you taking the time, and my contact information is on the screen now. If you would like to have a conversation, I'd be more than happy to schedule some time with you. Just give me a call on that number or shoot me an email. We can schedule an appointment. But again, thank you for your time, and I appreciate your interest in Urjanet.